Rotary kiln working principles and function in cement production. A rotary kiln is a pyroprocessing device used to cause a chemical reaction or physical change in a solid material through the application of high temperature. They are used to carry out processes such as calcination, sintering, organic combustion, heat setting and thermal desorption. Materials produced using rotary kiln include cement, lime, refractories, metakaolin, titanium oxide, alumina, vermiculite, iron ore pellets. They are also used for roasting a wide variety of sulfide ores prior to metal extraction. The basic components of a rotary kiln are the shell, the refractory lining, support tires, riding rings, and rollers, drive gears, and heat exchangers. The rotary kiln was invented in 1873 by Frederick Ransom. Kiln shell. This is made from rolled mild steel plate, usually between 15 and 30 mm thick, welded to form a cylinder which may be 230 meters in length, and up to 6 meters in diameter. Refractory lining. It may consist of refractory bricks or cast refractory concrete. The refractory selected depends upon the temperatures inside the kiln, and the chemical nature of the material being processed. The thickness of the lining is generally in the range of 80 to 300 millimeters. Tires and rollers. Tires are sometimes called riding rings, usually consist of a single annular steel casting, machined to a smooth cylindrical surface, which attach loosely to the kiln shell through a variety of chair arrangements. The tire rides on pairs of steel rollers, also machined to a smooth cylindrical surface, and set about half a kiln diameter apart. The rollers most support the kiln, and allow rotation that is as nearly frictionless as possible. Drive gears. The kiln is usually turned by means of a single girth gear surrounding a cooler part of the kiln tube. The gear is connected through a gear train to a variable speed electric motor. Heat exchanger. Heat exchange in a rotary kiln may be by conduction, convection and radiation. The kiln is often furnished with internal heat exchangers to encourage heat exchange between the gas and the feed. Principle of operations. The kiln is a cylindrical vessel, inclined slightly from the horizontal, which is rotated slowly about its longitudinal axis. The process feedstock is fed into the upper end of the cylinder. As the kiln rotates, material gradually moves down towards the lower end, and may undergo a certain amount of stirring and mixing. Hot gases pass along the kiln, sometimes in the same direction as the process material, co-current, but usually in the opposite direction, counter-current. The hot gases may be generated in an external furnace, or may be generated by a flame inside the kiln. The fuel for this may be gas oil, pulverized petroleum coke or pulverized coal. Rotary kiln in cement production. Raw materials employed in the manufacture of cements are extracted by quarrying in the case of limestones, slates and some shale, with the aid of blasting. Softer rocks such as chalk and clay can be dug directly by excavators. There are 4 stages in the manufacture of Portland cement: crushing and grinding the raw materials, blending the raw materials in the correct proportions, burning, calcining the mixture in a kiln, grinding the clinker together with some % of gypsum. The 3 processes of manufacture are: wet process. This is when the raw materials are ground wet and fed to the kiln as a slurry. Dry process. This is when the raw materials are ground dry and fed as a dry powder. Semi-dry process. This is when the raw materials are ground dry and then moistened to form nodules that are fed to the kiln. Crushing and grinding. Hard raw materials are first crushed, often in 2 stages, and then ground in a rotating cylinder ball or tube mills, containing a charge of steel grinding balls. It is done wet or dry, depending on the process in use, while soft materials are broken down by vigorously stirring with water in wash mills, producing a fine slurry, which is passed through screens to remove oversized particles. Blending. Thorough mixing of the material is ensured by agitation and vigorous circulation, induced by compressed air or by mechanical means. The slurry, which contains 35 to 45% water, is sometimes filtered, reducing the water content to 20 to 30%, and the filter cake is fed to the kiln. This reduces fuel consumption during calcining. Burning, calcining. According to the temperature of the materials in the kiln, the cement rotary kiln system can be divided into drying zone, preheating zone, decomposition zone, exothermic reaction zone, burning zone, and cooling zone. Drying zone. For the traditional cement rotary kiln, the temperature of the material in the drying zone is about 20 to 150 degrees Celsius, and the gas temperature is about 250 to 400 degrees Celsius. Preheating zone. The organic part of the raw materials begin to decompose, and the clay begins to dehydrate, preparing for the decomposition of calcium carbonate. Decomposition zone. The decomposition reaction of calcium carbonate mainly proceeds when the limestone is calcined. The heat between the material and the calcination zone is exchanged back and forth in this zone of the rotary kiln, so that the moisture of the raw material is evaporated. The temperature in this zone is over 700 degrees Celsius. The exothermic reaction zone. This is also called the upper transition zone. In a traditional cement rotary kiln, the temperature of the material in this zone is 1000 to 1300 degrees Celsius, and the gas temperature is 1400 to 1600 degrees Celsius. Burning zone. The material temperature is between 1300 to 1450 degrees Celsius, and the flame temperature can reach 1700 degrees Celsius. When the material temperature is close to 1300 degrees Celsius, tricalcium aluminate and tetracalcium aluminoferrite begin to melt and become liquid. Calcium oxide and decalcium silicate decompose, and tricalcium silicate will be precipitated when the saturation concentration reaches a certain amount. Increasing the temperature of the burning zone properly will help the formation of tricalcium silicate, which can improve the quality of the clinkers. Cooling zone, also called the lower transition zone. The temperature of the material is about 1100 degrees Celsius to 1300 degrees Celsius. After the clinker comes out of the burning zone, it is initially solidified in the cooling zone and enters the cooler for further cooling. If the clinker temperature is too high or too low when exiting the kiln, the clinker will corrode and wear the refractory material at the kiln mouth. If the temperature of the kiln mouth changes too fast, the clinker will cause thermal shock damage to the kiln mouth refractories. Grinding. The clinker and the required amount of gypsum are grinded to a fine powder in horizontal mills, similar to those used for grinding the raw material. Sometimes a small amount of a grinding aid is added to the feed material. For air-entraining cements, the addition of an air-entraining agent is similarly made. Finished cement is pumped pneumatically to storage silos, from which it is drawn for packing in paper bags or for dispatch in bulk containers. Chemical composition of cement. Portland cement is made up of four main compounds: tricalcium silicate, decalcium silicate, tricalcium aluminate, tetracalcium aluminoferrite. In an abbreviated notation, these compounds are designated as C3S, C2S, C3A and C4AF, where C stands for calcium oxide, S for silica, A for alumina, and F for iron oxide. Small amount of uncombined lime and magnesia are also present, along with alkali and minor amount of other elements. Use of rotary kiln. Building material industry. In addition to calcinating cement clinker, rotary kiln is also used for calcining clay, limestone and slag drying, etc. In the production of refractory materials, rotary kiln is used as the raw material to stabilize the size and increase the strength. Beneficiation process. Rotary kiln is used to magnetize and roast the lean iron ore, so that the original weak magnetism of the iron ore is changed to strong magnetism to facilitate magnetic separation. In the chemical industry, rotary kiln is used to produce soda, calcined phosphate fertilizer, barium sulfide, etc. Advantages of rotary kiln. Ability to handle a variety of waste. High operating temperature. Continuous mixing of incoming waste. Disadvantages of rotary kiln. High capital. High operating cost. Need for trained personnel.